Hello and welcome back to the course on machine learning. Today we're going to find out why machine learning is the future. Are you excited? I'm pretty excited. Let's get started. Alright, so here we've got a cloud, and it's a word cloud, and it just illustrates that data is everywhere. We live in the 21st century, and wherever you go, there's data. In fact, there's even a term for it, data exhaust. So as you go by with your day, you're constantly leaving this data exhaust. Whether it's through your text messages that you're sending, or you're going on Facebook, or you're just simply walking through the city and different antennas are picking you up, you're leaving GPS data. So you're constantly leaving this data exhaust, whether you are aware of it or not. And probably the only way to not leave data exhaust is to go live in the forest for a couple of days. So that's the reality we live in, and this data is just growing exponentially. It's accumulating all the time, and let's see how this has been happening throughout the history of the human race. So here we go. Since the dawn of time, up until 2005, humans had created 130 exabytes of data. So you're probably sitting there thinking, Kirill, that sounds really cool, but it is very hard to imagine what the heck an exabyte is, and means nothing to me. Okay, fair enough. So let's go and drill into this to understand what this actually represents. So here we've got a letter A, right? So letter A is a single letter, and a letter on a computer takes up 1 byte of data. Now if we zoom out 1,000 times, we have 1,000 letters, and 1,000 letters represents about a page on a small book, and that fits into 1 kilobyte. Now if we zoom out another 1,000 times, we have 1,000 kilobytes, which is a megabyte, and that is about a book with 500 pages double-sided. Now if we zoom out another 1,000 times, we get a gigabyte, and believe it or not, you can fit the human genome onto 1 gigabyte. So it actually takes about 725 megabytes of space, and you can encode, if you think about it, you can encode a whole human being on 1 gigabyte. But you'll probably say that a human is not just his genome, it's not just his DNA, it's also the life experiences that he has, all the things that he does in his life. You can't put that onto a gigabyte. Well, how about we zoom out another 1,000 times and we get 1 terabyte. And now if you take an HD camera and you walk around a person for his whole life, so for about 80 years, every minute, every second of their life, and you film everything they do, and you put all of that in HD video, that will fit into 1 terabyte. So that's already getting impressive, right? Now let's zoom out another 1,000 times, and this is one of my favorite representations. So here we've got the Amazon rainforest. It has about 1.4 billion acres of trees. Every acre has about 500 trees in it, so that makes it about 700 billion trees in the Amazon rainforest. So if you take all of those trees and hypothetically, I'm not saying this should be done, but hypothetically, if you take all those trees and you were to chop them down, put them into paper, and fill every single page of that paper with letters, with text, then you will get about 1 to 2 petabytes of data. So that should give you an idea of how huge a petabyte is. Now if you zoom out another 1,000 times, that's where you get an exabyte. So an exabyte is 1,000 petabytes. So now this should be a bit more impressive that since the dawn of time up until 2005, humans have created 130 exabytes of data. And that includes everything. That includes all of the books written, all of the songs that were sang, all of the words that were spoken. Everything that humans have created was about 130 exabytes of data. Now, in 2010, that number was already 1,200 exabytes. So you can see that in the following 5 years, humans create so much more data. Then in the next 5 years, in 2015, this number became 7,900 exabytes. Then in 2020, this number is estimated to be 40,900 exabytes of data. As you can imagine, these numbers are astonishing, but what's even more astonishing is the growth, the exponential growth of data that we're seeing. And if you visualize it, it will look something like this. This is the reality that we live in, the world that we live in, how quickly data is growing every single year. So this is an actual study. It was done by IDC and was sponsored by EMC. So this is all researched. Now, what is not researched is these lines that I'm going to draw now, but this is my impression of what's going on in the world. This is where I think we are as data scientists, our capacity to process as data scientists the data that's in the world. Then if you draw the machines, this is the line that represents how much of the data machines are actually using that exists in the real world. And so where does machine learning come into play? Well, machine learning is the potential, presents the potential to use this data that is not being used. Only equipped with machine learning algorithms can you step up to that challenge and make sense and add value from the data that is growing so quickly, in fact, exponentially. And that is why machine learning is actually a degree. It's been taught at universities. In fact, Hadelan, who is the second instructor on this course, he has a master's in machine learning. And throughout this course, I'll be sharing my intuitive understanding of machine learning with you, and Hadelan will be sharing his practical skills and applications that he's learned through his master's and through his real world experience applying machine learning. So we really hope you're going to enjoy this course, and we can't wait to see you throughout the classes. I'm sure by now you're pretty excited about what's to come, and you totally should be, because what we'll be presenting in this course is the cutting edge of data science and machine learning. Can't wait to see you in the next tutorial. Until then, enjoy machine learning.